Greetings and welcome. In this session we will discuss about the numerical to determine direction of flow and loss of head through a conical pipe using Bernoulli's equation. In a last video session we have seen a numerical based on Bernoulli's equation for ideal fluid, where the fluid in which there is no friction. Ideal fluid means a frictionless fluid. So in such cases there are no losses considered. But in real case or in case of real fluid, their loss of head is taking place due to friction of the fluid with the pipe material when the fluid is passing through the passage. So considering this head loss due to friction between the two locations in a flow, there is one more type of numerical which can be solved by using Bernoulli's equation. That is what we are going to see in this video session. So for that purpose, let us see statement of the numerical. So here statement is given: a pipe line carrying oil. Type of the fluid is oil. Specific gravity of the oil is given 0.8. Pipeline changes in a diameter from 300 mm at section A to 600 mm diameter at section B. This pipe is of conical shape. And section B is a 5 meter at a higher level. If the pressure at section A and B are 100 kilopascal and 60 kilopascal respectively, and the discharge through the pipe line is 300 liter per second. Determine, here two questions are asked to find direction, or first of all determine the direction of flow and then to find the loss of head. So for this, first of all we have to draw the diagram. From the help of diagram then we can proceed. So as per the given statement, conical tube carrying oil, specific gravity 0.8. So here we need to calculate specific weight of the oil, which is required in a Bernoulli's equation. So specific weight of oil can be calculated with help of the formula, that is specific gravity multiplied by specific weight of water as a standard fluid. So here we take specific weight of water 9.81 kilonewton per meter cube. So by this calculation, W of oil, means specific weight of oil, we get in kilonewton per meter cube. This value we will use in Bernoulli's equation. As per the given data, this is a pipeline. Here section A or location A, diameter is given 300 mm and pressure intensity is given 100 kilopascal. Other location or section B, diameter is 600 mm and pressure intensity 60 kilopascal. Section B is 5 meter above section A. So we take here this A as a level of section A. This line we take as a datum or reference line. Now we have to first of all find the velocities which are required to use in Bernoulli's equation. So for that we use here continuity equation, which is applicable for the incompressible fluid as the oil is given. Oil is incompressible fluid where the density of oil we consider that constant, remains constant throughout the journey. So continuity equation is Q is equal to product of area into velocity. So for section A, product A VA, section B, product AB VB. This formula we can modify and we write in the form of velocity. VA is equal to Q upon AA. AA further area of this tube at section 1 pi by 4 into diameter A square. Discharge is given in the pipe 300 liter per second. we take discharge in the numerical in meter cube per second. So 300 multiplied by, we have to do 10 raised to minus 3 divided by pi by 4 into diameter given here in an mm and we use in meter. So 300 multiplied by 10 raised to minus 3, that is a conversion from mm to meter, bracket square. Doing this calculation, we find the velocity at location A in meter per second. Similarly, we do the practice for velocity at section B by using this equation. So writing the equation, this equation for velocity at B, that is VB, is equal to what? Q upon this area AB. So Q upon area at section B will be pi by 4 dB square. Putting the value of discharge in meter cube per second, pi by 4 divided by area pi by 4 into, in a bracket, diameter B value, this in mm, here we write in meter. For this we do this conversion already discussed, then square. Doing this calculation, we get the value of this VB, velocity at section B. Now we use this velocity in further step of the problem. Now as this problem is of real fluid, so we write the equation including the head loss which occurs between section A and B, Bernoulli's equation. Now, as in the numerical, we are asked to determine or decide direction of flow. So for that purpose, how to decide the direction? So direction means flow always occurs from higher value of total head to lower value of total head. Means we have to find total head at both sections. So we write the formula in that way. So total head at section AA will be what? Summation of pressure head, velocity head and datum head at section A. So this will be what formula? Pressure head, PA by W, W of oil, as the fluid through the conical pipe is given W of oil, plus velocity square, plus this datum. Now putting the value, respective values, PA, pressure intensity, is given in the numerical 100 kilopascal. Kilopascal means kilonewton per meter square. W of oil we already calculated in the previous discussion, that is 7.85 kilonewton per meter cube. Plus velocity calculated, putting value here, divided by 2 into value of G, 9.81. As the location A we are taking as a reference, that is why that elevation Z, value of Z at A will be what? 0. So doing this calculation, we get total head at A in a meter. In the same way, we do calculation for total head at B by using expression PB by W oil, that is a pressure head at section B, plus velocity head at section B, VB square by 2G, plus datum head at section B, ZB. At location B or section B, pressure value is given 60 kilopascal, means kilonewton per meter square, divided by W of oil, which is constant specific weight, plus calculated velocity at section B square divided by 2 into value of G, plus location B is 5 meter above location A, so that is why plus 5. Doing the calculation, we get total head at B in a meter. Observing these two values, we find that total head at A is greater than total head at B. Means, as already we discussed, that flow of any liquid or fluid take place from higher head value to lower head value. So obviously here that oil will flow from section A to section B. So that is why direction of flow is from A to B. Now next part is to find the loss of head. To find the loss of head occurring between the two sections, we write Bernoulli's equation in the way total head at A means summation of all heads, pressure head, velocity head and elevation or datum head is equal to total head at B plus loss of head between the section A and B. Now already we have calculated total head at A that we use here, total head at B we use here plus HL means loss of head. Doing the calculation we find loss of head between section A and B in a meter. So in this session we have seen a numerical for the real fluid and we saw the procedure to obtain the direction, to decide the direction of flow and loss of head, to obtain the value of loss of head due to friction occurring between two sections. Let us meet in the next video session. Thank you.